This is the digital prototype of novel weaving machine. It is used for making the fabrics. This digital prototype was designed using the Autodesk Inventor Student version. It is 3D mechanical CAD software. This software is similar to Pro-E and SolidWorks. All parts were created and dynamically tested using this software. Parts technical drawings were also created using this software. CGD application software. This is application software created using the C language. It is used for finding the change gear teeth values. This change gears are used to control the fabric's threads per inch. Threads per inch means number of threads present in 1 inch of the fabric. Let's consider if gear A has 13 teeth, gear B has 53 teeth, gear C has 20 teeth, and gear D has 43 teeth. This gear teeth combination gives 83 threads per inch. If we need 100 threads per inch, we must change appropriate gear teeth. Here, gear A, gear B, gear C and gear D are unknown variables. Finding the respective gears requires a complex calculation, which is very time-consuming and is not possible in workplace. So I created a small application for this problem. Let us see the demonstration of this application. This application has two options. The option A is used to find the threads per inch, and the option B is used to find the gear teeth values. Another useful feature of this application is that it creates a log file of the output values. The log file maintains the record of previous calculations, including the time and date of creation. This is the source code of this program. Timer relay sensor. The bullet's traveling time is approximately 25 milliseconds from the firing end to the receiving end. In case the bullet doesn't reach the receiving side within this time, the machine must automatically stop. A timer relay control is used to monitor the bullet. ISIS Proteus Simulator is used to simulate the timer relay circuit. ADMEL AVR family, ATmega32 microcontroller is used to control the circuit. The receiving unit receives the bullet, and the IR sensor senses the bullet, and sends the bullet receive signal to the microcontroller. The microcontroller's port B pin 1 checks the bullet receive signal every 30 milliseconds from the timer relay, and the bullet receive signal is indicated by the bullet's receiving indicator. In case the signal does not reach within the appropriate time, the microcontroller's port A pin 0 goes to low state, causing the motor relay switch to turn off the motor, and the display displays the error message. This is a very important control system used in this machine. This microcontroller has been programmed using embedded C in AVR Studio. This is the source code of this program. (3D modeling using Blender). Blender is one of the leading, open-source softwares for 3D animation. Using Blender one can visualize their thoughts and ideas. We can virtually create anything using Blender. All the features of Blender like modeling, animation, physics simulation are very easy to learn, and it has a very user-friendly interface. Blender has powerful modeling, animating, composting and rendering tools. In order to visualize the working motions of the mechanisms, the weaving machine, its mechanisms, and its parts were designed in Blender. Later on this machine was developed using CAD system, taking the Blender model as a reference. Blender is very useful in studying the interactions of the machine's mechanisms in 3D space.